Welcome. My name is Nancy Copa. I'm with AEM. I'm the project director for the Common Education Data Standards, or CEDS. And today we are here to learn about how Maine is modernizing their SLDS through implementing a CEDS data lake with Apache Parquet. Next slide. We are pleased to have a number of presenters on today's webinar. We have Kathy Warren and Tori Ryan from the Maine Department of Education, Mike Reynolds and Ben Silberglitt from Cedar Labs, and Nathan Clinton, our CEDS lead architect. I would like to remind you that chat is enabled, and so if you have questions during the presentation, please go ahead and put those in the chat. We will be answering them at the end of the presentation. Next slide. So today you can see we're going to do a little bit of introducing the CEDS Data Warehouse Parquet, talking about why Maine wanted to do this, what was their business case, and then really going through the technical details around it. So how is it set up? What does it look like? That sort of thing. And finally, we'll wrap up with a few questions from you all and have our presenters answer those. So at this time, I'd like to turn it over to Nathan Clinton. Nathan?
Hello, everyone. Today we are going to introduce you to the CEDS Data Warehouse Parquet standard. We're really excited about this new release because it really helped bring states into the cloud for faster, easier, and more flexible data analytics and reporting. So this project really started with Maine, who came to CEDS with a request, and that was to build a CEDS-based data lake. And at the time, there were no resources available through CEDS to support that type of modern data architecture. So Maine and CEDS collaborated to develop and release the first version of the CEDS Data Warehouse Parquet standard. And now it's available on GitHub, available for anybody who would like to or is interested in a more modern data architecture. And clearly there's interest, that's why we're all here. So we hope you will join us out on the open source community to further collaborate, exchange ideas, release new capabilities, and share your stories. So I will hand it over now to Kathy and Tori to talk about Maine's story.
Good morning, everybody. I'm Kathy Warren, and I'm the Education Data and Data Systems Manager for MaineDOE. The overview of our project for today is to implement a self-serve system that provides key longitudinal data to a broad audience, for us to implement an SLDS for data management, visualization, and storage, and to design to implement and complement MaineDOE's strategical technical roadmap, and to connect Generate to the SLDS data warehouse. The Maine Department of Education's vision for their modernized SLDS is centered around our whole student approach and how to prepare students for college, career, and citizenship through investments in structures, people, systems, and practices. Improving access to quality data is a critical component of informing legislative and policy decisions, as well as personal and professional decisions. The MaineDOE's modernized SLDS will make data more easily available to all stakeholders, from policymakers to public citizens. For Maine, like many states, there's been a goal to invest in data warehousing technology that was going to support data-informed decision-making and to be as cost-effective and future-proof as possible. Our current warehousing is a heavily flattened relational data environment with limited capabilities for longitudinal analysis. This has made it difficult to fulfill requests from educators and policymakers and to look at trends over time and changes in the education landscape. It's critical that we evolve our approach to ensure that, in addition to collecting data and validating it to ensure reliability, that we give equal, if not greater, emphasis to making that data available for use. We bring a lot of data in many cases. It is often harder to get it out and get it to the people who really need to look at it. It was from this vantage point that Maine chose to pursue the SLDS grant in 2018. So our grant writing began in 2018, and our grant was awarded as part of the 2019 SLDS grant round. Oh, next slide, please. I'm sorry. 2020 was spent crafting our RFP, writing a phased, iterative, agile approach to the product development that would allow us to adapt our decisions as new information and options emerged. It was clear at that time that there were a lot of changes, potential changes in place, and and opportunities that would emerge. During 2021, we continued working on our policy and governance structure and invested our energy in remediating technical debt in our databases, while contract negotiations and final approval occupied most of the year. In 2022, we've had a significant reorganization at MaineDOE and several staff transitions. We had a hiatus with our state support team partners, and we began to examine how some of our initial assumptions about our technical infrastructure could be updated. This project continues to be a laboratory for resilience and adaptability, and we continue to learn about how to receive new circumstances as opportunities. The ability to pivot in adversity and realize greater value for our stakeholders is the difference between managing change and innovation, and this team has been really innovative. I have nothing but kudos for this team and their ability to ask the hard questions about how we can make this project the most cost effective and to do the best job to fulfill Maine's goals. I'd like to pass the story on from here to Tori Ryan, who joined as our SLDS project director in April 22, succeeding our former project director. And she and the rest of her team will share to you what's happened since.
Hi everyone, my name is Tori Ryan. I am Maine's Department of Education's Education Data Warehouse Manager. And like Kathy said, I started this job in April of 2022. So I've been very lucky to have spent 6 months working with a great team. So when we were looking at what we needed, we had needs, I think, that are similar to a lot of states that find themselves in the position of updating legacy data systems into something more modern. So what we found is that the legacy systems had fragmented data. There was frequently not a common sort of schema or language that or definition that we could be used in order to bring the data in consistently. So we were looking for a system with maximum flexibility to handle the sort of data that you get when you have multiple legacy systems of multiple different generations. And with that comes the need to clean up duplication. There are multiple data points that we are currently collecting in multiple places. And while we have some pretty good source of truth guidelines for using that data internally, we needed to make some decisions about how it's going to work when we put it all together in a single location. So we were hoping for something that would be able to support that the work we've been doing with the sourcing. We wanted something that would allow us to meet the needs of consumers as they continue to grow. We get asked more and more questions about students, teachers, administrators every year. There are more and more program areas within the department who would like to be doing some collections and or analyzing collections in ways that meet their programming needs. And we needed to have a system that would allow us to sort of bring in lots of data from different sources and sort of meet people where they were with what they needed. We were looking for a sort of single output type so that our EdFacts reporting and public reporting and generate implementation were all coming from the same body of information. And of course, as any resource-strapped state agency knows, we were hoping for something cost-effective, obviously, and something that would be scalable and kind of future-proof, as Kathy touched on, something that would be able to expand sort of beyond the needs that we could articulate at the time that we created the RFP. So that's what we were looking for in a solution. Next slide, please, Lindsay. And here's what we got. So I want to say that first, one of the great things about having a great partner is that we have these sort of 4 straightforward bullet points that seem pretty straightforward. They are actually, I know each of them is a really technically complicated piece of work, and all 4 of them are being handled really competently by our vendors, which allows Kathy and I to do the work that does not show up on bullet points like this. which is sort of the transformative cultural work of orienting the department to a new set of data systems, a new paradigm around data, and a sort of new way of thinking about past and future data. So I just want to shout out that having really great vendor partners has allowed us to do that. So what we asked them to do for us is implement the SLDS with using the CEDS standard to implement Generate for us. They have selected AWS as the implementation platform, and therefore they're using QuickSight reports with their with another contractor, eScholar, to duplicate and then expand upon the visualizations that we are currently holding in our data warehouse page on MaineDOE website. So with that, I'm going to hand it over to Ben Silberglitt, our great partner at Cedar Labs, who's been doing a lot of the technical work for us, and he is going to give a deeper dive into that technical part that we have paid him to do. So thanks, everyone.
Thanks so much, Tori, and thanks for that lead in. And on the flip side, being on the technical side, we sure appreciate Kathy and Tori's leadership in guiding and greasing the wheels of change across Maine so that we can come in and do this fun technical work and get the job done. So I'm going to talk a little bit about, I'm Ben Silberglitt, I'm one of the co-founders of Cedar Labs. I'm going to share a couple of architecture diagrams to just give you a big picture understanding of the project, where it is now and where it's headed, so that when we start talking about some of the individual pieces, including the data lake, you can understand where those fit in the overall project. So when Maine initially sent their RFP out into the universe, we knew it was a really substantial and complex project, and it really needed to be three things. It needed to be scalable, it needed to be cost effective, and it needed to be future ready. And so we thought a data lake was the perfect approach. Really, it provides the scalability and cost effectiveness of cloud native architecture, but it also provides the flexibility to handle both existing data challenges and also new data challenges as they arise, and be able to meet them quickly without requiring significant overhauls of data schema or architecture. So you'll get that performant, scalable, cost-effective architecture, but also that flexibility to change on the fly, which invariably happens in projects like these. We're looking years out and can't know what might happen then or what might be needed then to be able to be handled. And so not having to do those kinds of overhaul work each time a new problem comes in just makes the overall project a lot faster to meet Maine's needs and future ready. So this first diagram is the completed MVP. This is the part that we've completed to date. And as you move from left to right on your radio dial, I'll kind of walk you through the diagram. You've got data coming in from the state of Maine. It's historical data, over a decade's worth of historical student and staff information that we've brought in. We've brought those into staging tables. Those staging tables have allowed us to then prepare the data and move it into the CEDS data warehouse. I'll talk a little bit more later about kind of why that is arranged the way that it is. And there's a dotted line to Generate because we weren't on the hook in this first phase to actually stand up Generate and get it connected to data, but we did. We were able to get that stood up and create reports out of Generate in the cloud. So everything sort of, when you go past the state of Maine, that's all in the cloud in AWS, both in the Cedar Labs cloud and eScholar cloud. And so that CEDS data warehouse is stood up in the cloud. I believe that's a first. Standing up Generate in the cloud is certainly a first. And then now we've implemented this CEDS data lake as well, also in the cloud, which of course is a first. So we're bringing that data from the data warehouse. We're forking that off for Generate reporting, so Maine can continue to meet its federal reporting needs. But then there's that single pipe that Tori mentioned earlier. That's also bringing the data into this data lake and preparing it for the public-facing reporting and the internal reporting needs that Maine has. So that comes from the CEDS data warehouse. There are these, I'm not going to get too much into the technical weeds here, and I know Nathan and Mike are going to dive into that a little bit more in depth, but there are these glue ETL jobs that run that prepare the data, format it, according to CEDS specifications, flatten it into these Parquet files, and prepare those for querying and also for reporting. There's also these crawlers, these little bug icons that you see on your screen. Those provide the glue catalog information that helps us know what's in the data lake and helps us prepare the data dictionary that you might need, that you'll definitely need in order to keep track of where your data are and where the tables are and what information is in those. And then all of those data are available via AWS Athena for direct query in a SQL language. So your folks who know SQL can continue to use SQL to get at that data, even though it's now in these Parquet data files. And then we're also bringing that data across accounts. Mike's going to talk a little bit more about cross-account access, bringing that data into the eScholar cloud, where eScholar is putting that data into Spice, which I never remember what it stands for, but Mike will tell you what that acronym means, and then preparing that in Spice for reporting via QuickSight. And that's where the public reports, dashboards, et cetera, will be created. So all that work is what we've done to date. It was about a 6-month project to put all of that together, kind of learn how to implement those things CEDS style, work through some of the troubleshooting of some of these firsts of implementing on AWS. And Mike's going to talk a little bit more about that AWS implementation and what all was involved there. All of these components, the staging tables, warehouse, generate, and data lake, those are all open source tools. They're part of the open source community. And of course, as part of the project, we plan to provide information back to the open source community to help other folks that are looking to do this as well, right? That are looking to move their CEDS, SLDS infrastructure into the cloud. Next, if you can go to the next slide, Lindsay, I'm going to talk a little bit about where we're headed in the project. And so what we've done so far is pull in data, again, moving left to right. We've pulled in historical data from Maine's Department of Education. What we'll do moving forward is start to pull in real-time data, both from Maine's school districts across the state through the Maine Department of Education, but also additional systems of data that Maine wants to bring into its SLDS. So University of Maine, finance, labor, teacher certification, community college data, all of these disparate sources of data can come in. And what we've implemented in the eScholar Cedar Labs solution on the left-hand side, we'll implement this tool that Cedar Labs, it's a proprietary tool that Cedar Labs calls the Data Hub. And what that does is it gives Maine the ability to bring all these disparate sources of data in whatever format they happen to come. And then we can provide validations on those data, bring those into an operational data store, provide the transparency to see that data flow as it comes from those systems and gets transformed. And then we can prepare and transform those data for consumption by really any system that needs to consume them. For this project, we're focusing on the CEDS data lake. And also eScholar is providing a unique ID process or a unique ID software system that will provide person matching. And so what that's going to do is give Maine the ability to really track individuals from cradle to career and connect them across disparate systems that weren't developed with a common identifier. And so providing that connection, it's really key to have this Data Hub tool that's going to be able to provide the back and forth conversations between those systems and also provide that flexibility to manage the data, validate it, and audit any of and provide transparency to that data and troubleshooting tools as that data gets consumed by multiple systems. Then we've taken all that complexity that you saw in that first diagram around the data lake, and we've just shrunk that down into one box just for the sake of space. What's going to happen there is we'll be moving towards more of a lake house approach. Nathan will talk a little bit about what that means a little bit later in the webinar. And we'll also, as Generate evolves, Generate will be able to feed directly off of the data lake itself, rather than needing to have that CEDS data warehouse in between Maine's data and the data lake where it is currently in that previous diagram. So that data warehouse can go away. We can go directly into the data lake or lake house, and then Generate can feed off of that, consume that data, and provide the advanced reporting. That's obviously a little bit into the future, but those are some of the challenges that we'll be working through and again, working as we can to support the open source community to evolve those products to support other states that want to implement similar approaches. And then that lake house will be available for reporting and direct query as they were in the previous diagram. So that's a little bit of a walkthrough on what we've done so far and kind of where we're headed from an architecture perspective. And hopefully that gives you a sense of where these pieces fit as we dive into some of the technical specifics of those pieces, as well as their implementation in the cloud. And to start off on some of those pieces, I'm going to hand it over to Nathan.
Great, thank you. So I'm going to introduce you to the more technical side of Apache Parquet. So first, it's open source, like everything Apache does. It means, one, it's free to use, free to distribute files in that format, and all the major data engineering tools, query engines, BI tools can work with Parquet. So it's a very flexible and accessible tool. It's a column-oriented data file format. And most importantly in that is that it's a data file format. It's essentially just files, a series of files, meaning it's really compatible with a data lake architecture. But also, it's a column-oriented file format, which is different than a traditional database where most of the data is stored in rows. And that's what probably a lot of us are most familiar with. And in a lot of cases, a row-oriented format still works great, and it'll continue to work for years to come. But with analytics, storing data in rows isn't quite as efficient as we would need it to be. So columnar data changes the way that we use data in a couple of ways. For example, say you have a set of data, you have 30 columns worth of data. When you bring that into Parquet, say you only need 3 of those columns. With columnar data, you only have to look at those 3 columns worth of data. The rest of the file is ignored. That's not true with row-based technologies. You have to look at each row to find the data you're looking at. So also, Parquet doesn't duplicate data. So within each column, it only saves the distinct values, and then there are pointers, row pointers to the values. So it saves space and not having to duplicate that data. Really, in education, that's very useful because we have a lot of statuses and dates and things like that that end up being duplicated. So you save a lot of space and time and processing time with that feature. Also, Parquet automatically compresses data. So there is a huge savings in space. When the official line is that there's Parquet takes 1/6 the amount of space as a traditional row-based format compared to like CSV or text tab delimited files. But I've seen that decreased up to 90% in personal experience. Apache Parquet is structured data. And yes, it's essentially text files that are being saved to a data lake, but the metadata for your data file, your actual Parquet file, is saved within the file, meaning it then becomes structured data. So you have your column names, the data types, and there's even ways to include other additional metadata. We're looking into ways to store CDS definitions directly into the file. And that's important for a few reasons. First, the data cataloging tools like AWS Glue Catalog, Microsoft Azure Purview, they can scan these files and automatically detect what data is in those files. And then if there's a change, they can alert you to those changes. If you added a new column or a column changes, they can alert you to those changes. Also, from a CDS perspective, we're bringing along the CDS terminology into these files. And that's really important so that we are all using common terminology and embedding it directly in the data. And if we're able to bring in the CDS definitions, you're literally bringing your data dictionary, your CDS data dictionary, along with that data. So it's very powerful from a data standards perspective. Next, Parquet is in a data lake is great query performance. So this format is really built for big data and can scale up to petabytes worth of data. And traditional, more modern data engines, like what we're using here in Maine, Athena, or other tools like Redshift, Azure Synapse Analytics, they can scale horizontally. And so if you need more processing power on demand, you can add more processing power to your clusters, and they're able to spin up fast and give you better performance. If you compare that to a traditional SQL kind of world, that's a little bit more difficult, because generally what one option is to scale vertically, increase more CPU time or memory, and that is more expensive and complicated. Lastly, Parquet is really easy to work with because it's a file form. Create Parquet files and read them in. You also have these cataloging tools. So if you have, hopefully my internet is okay, and I just got notice. If I'm coming through choppy, just let me know.
You went out for just a second, but you're back, Nathan.
Great, thank you.
Mm-hmm.
Okay, let's see, where was I? Right, okay. So if you add a column or change a column, the cataloging tools, they will notice those changes, and you can then absorb that into your data governance process. But it makes it very easy to manage change in your data lake. And also, you don't necessarily even have to go back and update your old files. You can leave those as they are and just worry about changes to your new files over time moving forward. Next slide, please. So for some details on how we came to the final format, the actual standard itself, we wanted to have a one-to-one correlation between the CDS data warehouse and the CDS data warehouse Parquet formats. So for each fact table in the CDS data warehouse, the star schema, we created a version of that in a flattened Parquet file. Same for some of the ancillary dimensional data, slowly changing dimensional data. But what was really important for us is to have that one-to-one correlation. We didn't want to have reporting capabilities that were available in one of these two technologies that wasn't available in the other. Because we were able to, because with that decision, we were able then to automate the creation of these the standard documentation and additional tools that we've made available to convert from the warehouse to the Parquet files. Slide, please. Diving into that a little bit further, as I mentioned before, for every fact table, there is an equivalent Parquet file standard. So you then also that for every slowly changing dimension, so say the list of all of your school districts or schools or students, there is an additional Parquet file standard for that data. Within each of these files, particularly the fact tables, we wanted to bring in all the dimensional data. But when you look at the data within those dimensions, a lot of the elements are duplicated. So we needed a way to deduplicate and uniquely identify those columns. And to do that, we brought in the name of the dimension table minus the prefix of dim, D-I-M for dimension, underscore, and then the CDS element name. So for example, K-12 schools underscore name of institution is where you would find the name of the school. There are also several bridge tables in the CDS SQL star schema data warehouse, which allows for one-to-many data relationships. So for instance, a student can have identified as multiple races or have multiple disabilities. To bring that into the Parquet format, we bring that in as a pivot. So for every race option, we turn that into a unique column. So there's a column for Black, White, Asian, Alaskan Native, so on and so forth, with binary options within that. The same for all of the discipline, or sorry, IDA disability statuses. Okay, next slide, please. So I mentioned before, this is all out on the CDS GitHub repository. So there's a link there, and we'll have that up again later on. So if you don't capture it now, you can. Oh, thank you, Nancy. When you go out to this repository, you'll find that there are two main folders. First is a folder called Python SQL DW to Parquet. And this is the Python script that we use to kind of develop the standard. And with that, it takes data from the data warehouse using a series of SQL views that we created, and will actually create the the Parquet files for you. So you can convert your data from the SQL data warehouse to Parquet format. In this project, the Cedar Labs team, they use the SQL views to do a direct extract from the warehouse and bring that into their data lake. So the second folder is where we have our documentation, and we have a spreadsheet out there that describes what each of the files are, what the names of those files should be, plus all the technical details. So the names of the columns, all the data types. So that is essentially the standard itself. Just to give you an idea of our release process, so you can get kind of an idea what our process is for updating the standard. Because we have that one-to-one correlation between the Parquet standard and the data warehouse, all changes originate in the SQL data warehouse. Because it's a more complicated structure, we want to make sure we have compatibility there first. And we tried to strike a balance between an annual release cycle, which was more traditional with CDS, and longer release schedules for standards is pretty common. But we wanted to have, as the spirit for open source solutions, a faster turnaround on changes. So for non-breaking changes, we have a 60-day community review period. For breaking changes, we have a 90-day review period. We still have an annual release cycle for any changes that need to be brought in from the major CDS release. But because the Parquet file format is a derivative of the data warehouse, and we automated the process, as soon as a version is released of the data warehouse, it's a very short turnaround to get the Parquet standard updated. And we do not have that same window because they're one-to-one. Okay.
All
right. With that, I'll hand it over to Mike to talk about their implementation details.
Thanks, Nathan. Hopefully my voice holds up through this. I just came down with a little bit of a sore throat, but I think we should be okay for a few minutes. So just to reinforce what Nathan was talking about, the CEDS data lake is based on open standards and open technology. There's a lot of different ways to skin it. What I'm going to walk through specifically is the Maine implementation, which takes advantage of the cohesive set of native AWS tools. So this is basically, I'm just going to chunk it up into 4 different service chunks that we went with, and kind of give reasons why. So the top one there is RDS, the relational database service. That is the host for the Microsoft SQL Server that hosts both the staging database and the CEDS data warehouse. The next service chunk is called Elastic Beanstalk. That's where we're hosting the Generate.net web app and the Generate.net background web app. Then the last 2 are the lake formation and the glue, which, as we saw in Ben's diagram, is sort of the biggest piece where the actual data resides, and the glue jobs that move the data from one segment to another. And then at last, there's the QuickSight, which is the enterprise reporting tools. And before we get down into each of those services, we're also busy working on a white paper that describes more detailed steps than we'll be able to get into here for obvious reasons. We're going to be releasing that white paper. Like I said, we're working on it right now, and it's going to go through sort of detailed steps for standing up each of these pieces in the AWS cloud. All right, next slide, please. Oh, yeah, there you go. So the first chunk of services are called RDS, the Relational Database Services. AWS has a number of purpose-built persistent stores, document stores. So they have, you know, the Elasticsearch document store. They have time series document stores. They have graph databases. The RDS is specifically for more traditional relational database services. There's a lot of really great integrations that RDS provides with the rest of the AWS ecosystem. It ties in with their network security. It ties in really well with lake formation. It provides a really great level of troubleshooting and monitoring, so that it's much easier for us to manage these large implementations. And it helps us also to debug situations when there are, you know, when there are performance bottlenecks. There's a number of sort of cloud native tooling that's built in that helps us deep dive into figuring out exactly what's slowing things up. On each of these service chunks, I'm also going to talk about things that we learned. So not necessarily roadblocks or you know, hiccups. It's more just things that we learned about and that you should maybe either keep in mind when you're deploying these, or things that we're going to be writing the white paper on, so that it's easier to deploy. So the first thing we learned was when we need to deploy the generate data warehouse, or the CEDS data warehouse, we get the backup file, and the way that you get that backup file from GitHub into into the RDS is you upload it to S3, which is the sort of file system, the cloud native file system in AWS. You have to create a custom option group with your SQL Server database. And again, we'll be documenting what that is. It sounds a lot worse than it is. It's actually just a 5 or 10 minute task to create that custom option group. And then you just simply run a restore from backup that points to that S3 file that you uploaded using that option group, and all of a sudden you have the restored backup. So it's a little different than doing something on premise where you have access to the file system natively. There's already good documentation for it on Amazon, but we'll be writing up the details on what we did for that. All right, next. So Elastic Beanstalk, that is the application sort of bundle provider that AWS provides. A lot of times you have web applications or non-web applications, in the case of the background app, that all require sort of very similar pieces. It requires a load balancer, requires network security. A lot of times it requires connectivity through your VPC back to the databases. Elastic Beanstalk kind of bundles up those pieces together and lets you focus on your deployment of the application suite, rather than binding all these little modules together. There's a lot of different support for different application frameworks. It handles Java, it handles Node. What we used was the .NET application for Generate. There's also a really nice set of tools to take it from your IDE and Visual Studio in this case. And there's a set of AWS plugins, which when you have the Visual Studio with the plugin all installed, it's basically a button click and answer a bunch of configuration questions, which made deploying Generate really painless. I was not looking forward to figuring out all the different meta settings that you need to configure to run it in a cloud environment, especially in a production cloud environment where you need to make sure that you're secure and make sure that you're able to scale. But really, this AWS plugin made it very simple once we got that installed. And again, this is also going to be part of the white paper that describes step by step to get those pieces installed. The other piece that we put in place there, and Nathan was talking about the open source nature of the CEDS ecosystem. When we first wanted to roll this out, obviously one of the main components is security, and it initially presumed that you had a production Active Directory to plug into. What we wanted to do was configure sort of an embedded user pool for sort of a smaller implementation to get us kickstarted. We needed to make sure that everything was super secure, so we didn't want to take any shortcuts. So what we ended up doing is actually creating a number of sort of patches to the open source project that were then rolled in, and we can now configure the embedded auth users without having to stand up a production Active Directory system. Now in the future, when we do plug into the statewide Active Directory, it's just going to be a configuration change. It's not going to be a code change. It'll just be some more flags that we set in our configuration parameters, and we can then, we can then just redeploy without having to have any big code changes. All right, next slide. Final and the largest piece of functionality that we're using with AWS is the lake formation and glue. Lake formation is that takes into account the Parquet files. There's a series of tools such as the crawler that Ben was mentioning that basically looks at all the different data structures and creates the meta information to be able to query those Parquet files as if they're almost like a relational structures. Glue is a set of ETL scripts. Those are basically Python scripts that move the data from the AWS RDS staging tables from the data warehouse, and then moves them into the different stages of the data lake. Really, the biggest thing that we ran into in dealing with lake formation and glue is just the rate of innovation that is coming from AWS on these particular tools. This isn't decades old technology that the dust has settled on. They're just constantly innovating. In fact, we have on our roadmap the lake house concept is still being fleshed out and will be productionized over the next year or two. We do have good access to Amazon resources that help us sort of plan our development cycle so that we're ready to take advantage of these new architectures once they become available embedded. And along with that, there's something called the AWS Data Lab. The AWS Data Labs are week-long, maybe longer sometimes, labs where we get to sit down sort of shoulder to shoulder with very in-depth detailed Amazon architects, where we walk through best practices and make sure that we sort of come out of the chute on the right with the right architecture, and make sure that we are thinking 3 steps ahead, so that when these new architectures come out, that we're ready to take advantage of them. All right, next slide. And finally, there's QuickSight, which is Amazon's enterprise reporting. We chose that it's the natural end product of all the other data lake stuff that we put together. It is very well integrated with the rest of AWS's ecosystem. It's a really nice set of tools to be able to generate reports. It has data governance built in. It has security built in. It comes with a really nice set of report creation tools. One thing that QuickSight in particular allowed us to do was to do this cross-account sharing, where basically the data structures were all maintained on the Maine and Cedar Labs AWS cloud, but then we are able to have a sort of remote access authorization for eScholar to bring just the pieces of that data lake that they would be working with and bring those pieces into their cloud. So we're able to decouple the two different clouds and delegate administration of the reporting layer to eScholar. Ben promised that I would tell you what the SPICE was. SPICE is the super fast parallel in-memory calculation engine that is used by QuickSight. It's basically a cached version, very intelligently cached version of the data lake. And it just makes it so all of the reports are running against the fastest sort of in-memory buffer of what the data lake is. So you can query it, you can treat it almost like a regular old data store. It's just really fast and really inexpensive to use. And really the QuickSight, we took advantage of those same data labs that we did for lake formation. QuickSight's evolving at least as fast as the lake formation is. And so it was really great to be able to get a sort of a bird's eye view of both where it is now and also where it'll be going in the next few years, and allow us to plan our iterations and release dates according to what's going to be released. All right, thanks for sticking with me. I'm about to lose my voice completely, so I'll hand it back over to Nathan.
All right, so I'd like to talk about next steps, and really, I think it's important to kind of talk about why this approach was really important to us as members of the CEDS community. And so we've talked a bit about kind of the evolution of data architectures, and CEDS wants to be wherever you're at. Right? So if you are still on premises, we have the CEDS SQL data warehouse that you can use to do your analytics and reporting. With the Parquet release, we now are able to, CEDS is now able to give you functionality in a data lake. Data lake currently is kind of a mix of traditional data warehousing along with files in your data lake. So that's kind of how folks look at a data lake right now. But then there's this concept called a data lake house, which is you no longer have a traditional structured data warehouse. You are doing all of your analytics and reporting through a metadata and governance layer directly on top of your data lake. And with this new Parquet standard, combined with the SQL, traditional SQL database, CEDS is able to meet you at any one of these three evolutions of data architecture. So again, we really hope you can that you're interested. We're happy to discuss this more with you if you're interested in using it in your organization. And to learn more, please go out to the GitHub site. Again, the link is at the bottom of this page here, and Nancy posted in the chat earlier. So please go out and take a look, and we hope to talk to you.
Great, thank you. Thank you, Mike, Ben, Kathy, Tori, and Nathan. We have just a few minutes left, so if anyone has any questions, feel free to drop them in the chat, or you can go down to the reactions and raise your hand. Just as a reminder, these were the presenters, so if you want to address someone in particular, or if you have a general question, we'll pause a moment for you to do that. While folks are getting together their questions, I do want to let you know that tomorrow we will be sending out notifications, so look for that, around a new webinar series. It's called the CEDS Masterclass. We will be holding 3 webinars, the first one starting on November 17th, then December 1st, and December 8th. These webinars are for novices and experts alike, so We hope that you will join us for these webinars. They will cover things like the future of CEDS, the various technologies available using CEDS, and additional states and how they are using CEDS or expanding it, much like Maine has here today. And are there any questions that anyone would like to have addressed? Okay, not seeing any. I want to just thank everyone for coming and participating in today's webinar. And again, we would like to thank Kathy, Tori, Mike, Ben, and Nathan for presenting this information. We are very excited about the Parquet repository that's now available on GitHub and all of the work that Maine and Cedar Labs has done towards this. So thank you very much, and we hope you have a great afternoon.